In this movie, we're going to look at variable proportions in the scaling. So we've seen how we can tie the proportions together and make a fixed proportion scaling. We've seen how we can set up a family that has no relationship between the various dimensions. Each one can flex independently. You can also set up relationships where you actually create a scale factor or a multiplier that you can build into the family so that while you're tying together various dimensions and making them scale proportionally, you maintain some control over what that proportion actually is going to be. So I'm in a file here called Proportional Sandbox, and I have some instances of a Gothic arch placed on the surface. And it doesn't matter which one of these you select, they're all the same. So I'm going to select one of those and click Edit Family. So this is a face-based family, and when I get in here, you can see that it's just a simple sweep. So if I select that sweep, the way I've set this up is that it's using a profile. So if I scroll through here, there's a profile that I have called rectangular proportional. So it's just a simple rectangular shape, and it's currently scaling proportionally. So if we were to vary one of the dimensions, they would both vary the same amount. So you could see that if we expand families, expand profiles, and the name of the type that I've created in this family, I just called it Flex. That's the generic name that I use for families when I don't want to indicate the sizes. I want to indicate that it's just a flexible type. So I'm going to right-click that and choose Type Properties. And if I change either one of these numbers, I'll change it to 0.6, you're going to see that the other one changes accordingly. And we've seen this before. This is what we've been doing in the previous movies. So what if you wanted to be able to have that behavior, but also be able to have the possibility of scaling it disproportionately if you wanted to? In other words, changing the multiplier. Well, right now that multiplier is built in. Now to see that multiplier, we have to open yet another family. And see, that's really the problem, is that do you want to have to keep editing families every time you want to make these changes? So let's right-click Rectangle Proportional and choose Edit, and that will open that profile family. Pretty simple profile family, a couple of reference planes, few dimensions. I'm going to go right to family types for this. So here's my X and Y, and you can see that I currently have a multiplier in there of 0.3. And so that's built in. There's no way to change that once it's nested into a family. But what if you wanted to make it editable from the family? Well, what you do is you create a brand new parameter for that. So I'm going to click Add here, create a new parameter that I'm going to call multiplier. The kind of parameter that this has to be is a number. Now, the reason it has to be a number is, if I move this out of the way, that 0.3 in the background that we're using in the formula, I'm going to replace that with this multiplier parameter. So you want to make sure that your multiplier doesn't have any units. If you chose length as the parameter type, it's not going to work because when it multiplies x by length, it's going to come up with square feet or square meters, and that's going to cause it to fail. So this is why it has to be a number. It has to be a unitless number. I wanted number because I want to allow decimals. If you want a whole number, you can choose an integer. But in this case, a number is what I want. Revit's going to suggest putting that under Other, which you could do if you wanted to. But because I want my user to be able to manipulate this, I'm actually going to override that and put it under Dimensions. Now, some folks don't like it under Dimensions. If you prefer, you can put it in Constraints or really any grouping that you want. This is just organization, so it's not that important where you put it. So I've called it multiplier, type of parameters number, and I've got it under dimensions. And I'm going to start off by setting that multiplier to 0.3. So I'm going to set it to the number that's already here. Now what I need to do is change this formula, and instead of 0.3, I need to write multiplier. You must spell it exactly the same way as you have here, case and all. Now, when you do, that will gray out that y dimension. I can no longer modify that y dimension. Now, the way I've set this up is a really simple example of the concept. We're driving the y parameter from really both of the other parameters here. We're driving it from x and from the multiplier because we're multiplying the two of those together. So notice that x is still free to be any value it wants. So if we change x to something like 0.8, that will actually modify the y because x is part of the formula there. And if I click Apply, it maintains the same proportions. However, if I change the multiplier to say 0.4, or let's do something a little larger, maybe 0.6, and click Apply, notice that that only affects the y. So the way I have it currently set up, I can maintain the proportions by modifying the x, or I can change the proportions by modifying the multiplier. Now, if you leave it that way, you might want to rethink the names a little bit, because will it be obvious to your end user that modifying the x actually drives both the x and the y? Not really sure. So it might be good to change that name to something more descriptive. And likewise with the multiplier, maybe you change that to proportion or something along those lines. But the really important thing here is to understand the concept. By using a multiplier parameter, you gain this ability. So let me take this family and load it back into its parent family and show you where that applies there. So I'm going to cancel out of here, and I'm going to load this back into the Gothic proportional profiles family. That's the Gothic arch family. It'll ask me if I want to overwrite the existing. I'm going to overwrite everything. So I'm going to click this bottom choice here, and you can see that it just grew a little bit larger. So if I select the object, we're still using the profile rectangular proportional flex. But now if I want to access that multiplier, I can simply come down here in the project browser, expand that family. Here's the flex type. If I right-click it and go to its type properties, I have access to the multiplier right here. And I could change it back to 0.3, for example. When I click OK, you're going to see the proportion change. Now, if I decided to push that just a little bit further, we can go to the type properties again, and notice that sitting over here, we have access to the Associate Family Parameter button. So now I can link up a parameter here in the current family that drives the nested subparameter in the nested family. So I'm going to add a parameter for this. Notice the type has to be number, and I'll call this multiplier again just to keep it the same name. I'm going to put it under dimensions. Click OK. OK again. That grays it out. It's now driven by that parameter. When I click OK, now if I go to family types in this family, I now have a multiplier right here, which will ultimately reach in and drive that proportional parameter in the nested family. So I'm going to change this to 0.2 and click Apply. It gets a little thinner. I'm going to change this to 0.4, click Apply. It gets a little thicker. Let's click OK. And so you can see where the utility of setting up that nested parameter comes into play. It's a little bit more setup and work that you have to do to define that, but it gives you ultimately a lot more flexibility in the way that you build your families, allowing you to either have fixed proportion or to override that fixed proportion by using a multiplier.